Hello students, welcome to Well Explained. Today I am here with class 10th electricity lecture number 2, electrical resistance. Now what is resistance? Resistance is defined as an obstacle to the flow of electric current, or it is also said that it is the opposition offered by any object to the passage of an electric current through it. In Ohm's law we studied that is R is the constant of proportionality and this is resistance. Now resistance of a conductor depends on the following factors. Number 1 is the length of the conductor. Number 2, area of cross section of the conductor. Number 3, temperature of the conductor. And number 4, the nature of the conductor. That is, of what material this conductor is made of. Now coming to the first factor, that is length of the conductor. The resistance of a conductor is directly proportional to the length of the wire. That is, longer the wire, greater will be the resistance, and shorter the wire, smaller will be the resistance. If L represents the length of the uniform wire and R is the resistance, then R is proportional to L. Now the second factor on which the resistance of a conductor depends is the area of cross section, and area depends on the diameter because wire is considered as the cylinder, the diameter of the conductor. Resistance of a conductor is inversely proportional to the area of the cross section of the uniform wire. That means thinner the wire, greater is the resistance, and thicker the wire, lower is the resistance. If A is the area of cross section of the uniform wire, then R is proportional to 1 by A, or in other words we can say R is inversely proportional to 1 by A. From this we can easily say that if the area of the cross section is doubled, the resistance of the conductor will become half, and if the area of the cross section becomes half, the resistance becomes doubled. You can see in this figure, if the cross-sectional area is doubled, twice as many electrons became available to flow, so that the current is also doubled. Now the third factor on which the resistance of a conductor depends is the temperature of the conductor. The resistance of a metallic conductor increases as the temperature increases, example copper, and decreases as the temperature decreases. But the resistance of a semiconductor or insulator, it decreases as the temperature increases. Now the fourth factor on which the resistance of a conductor depends is the kind of material, that is resistivity. The material also affects the resistance of a conductor by a fixed amount for different material, and this is known as resistivity, which we are going to study in the lecture 3. That resistance is equal to rho into L, that is length of the conductor, upon A, that is the area of cross section. The rho is the constant of proportionality. If we join the first and the second factor, that is R is proportional to L and R is inversely proportional to area of cross section. If we add these two, R is proportional to L by A, and this proportionality sign is displaced by the proportionality constant, that is rho, which is known as the resistivity. Now kind of material on the basis of resistivity, there are resistors, there are good conductors, resistors and insulators. Good conductors are those substances which have very low resistivity or very low resistance, and they allow almost all the current to pass through them. The resistors have comparatively high resistance, so they oppose the flow of current through them. And the third type of material on the basis of resistivity is the insulators which have very high resistance. So no current can flow through them. Examples of good conductors are all metals. The silver is the best conductor of electricity. For resistors, examples are the alloys like Constantan and nichrome. And for insulators, the examples are plastics, rubber, wood, etc. You can see from this table, conductors, alloys are the resistors and the insulators. The resistivity of conductors is very low. It's in the power of minus 10 to the power of minus 8. Whereas you can see in insulators, it is up to the positive powers up to 10 to 14, 15 to 17. You can see glass having 10 raised to power 10 to 10 to the power of 14. They have very high resistivity. That means they do not allow the current to pass through them. That is why they are known as insulator. That's all for the today's lecture. Thanks for watching. Have a nice day. Don't forget to subscribe my channel and press the bell icon so that you may get the notifications whenever a new video is uploaded.